Salutations to you viewers across the world. This is Chico Squared, the maths and science guru. In this discussion, we're going to focus on chemical bonding. But specifically, we're going to be doing ionic bonding. Video covalent bonding, and it right. So, what is ionic bonding? Before we discuss specifically what ionic bonding is, let's discuss about bonding in general. Right, for chemical bonding, two or more elements, and you know the two or more elements can combine to form what is called a compound. And pano combine two or more elements to form a compound. My atoms are combined to form a molecule and right. So the way in which atoms combine to form molecules differs. All right. Kuna ionic, kuna covalent, kuna dipole, kuna van der Waals forces, etc. But ionic bonding. Ionic bonding is bonding between a metal and a non-metal. Alright? So whenever you have a metal and a non-metal, one thing you need to understand is that you are dealing with ionic bonding. And the next question is, how do you identify that this is a metal? How do you identify that this is a non-metal? Uchishandisama configurations. And right. Element in between 1 to 3 electrons in the outermost shell, all right, it's called a metal. So a metal has between 1 to 3 electrons in the outer shell. A non-metal has between 4 to 7 electrons in the outermost shell. And then a noble gas has 8 electrons in again the outer shell rakaza. So a metal and a non-metal will give ionic bonding, whereby metals are known as electron donors. I not donate my electrons, and then my non-metals are not accept my electrons. And then after my metals are donate my electrons, they become positive charges. And then when non-metals accept electrons, they become negative charges. All right. And after a metal donates electrons, it has to remain with 8 electrons in the outermost shell. We call this a stable octet. And then after a non-metal accepts electrons, it also has to have 8 electrons in the outermost shell. We call this a stable octet as well. So let's proceed further. We want to look at an example, chemical bonding in sodium chloride. All right. Saga ngatungo sodium chloride. So the example we want to discuss today. All right. First, if you check sodium in the periodic table in this nuclide notation, and then chlorine in the periodic table in this nuclide notation again. So which means the electronic configuration for sodium, if it has 11 electrons, you can get it 281. So 281 is the configuration for sodium, and then 287 is the configuration for chlorine. So if we are to draw these atoms, this is how they look like. You have sodium, first shell contains 2, next shell contains 8, last shell contains 1, and then you have chlorine having the following. Some dots in this case now, just to show that these electrons are coming from different sources. So you have chlorine having the following electronic structure. So chlorine is 287, as you can see, sodium 281, as you can see. So what happens is that the sodium donates 1 electron and gives to chlorine. And after this has happened, what you are going to realize is that this sodium is now left with a stable octet, 8 electrons in the outermost shell. And after this has happened, the sodium is going to accumulate a plus charge on it because you have visa 1 electron. So whenever we see a positive ion yakanyorwa Na plus. What it means is that this is sodium yabvisa one electron ikabva yasara a positive charge. Then for chlorine, this is the situation yatinosara nayo. After it has received one electron, this is how it is going to look like. So this is minus, all right? It's a negative charge, all right? So we have an Na plus and Cl minus ions in this ionic compound, and the formula in English is NaCl. I hope you have understood, ladies and gentlemen. For online and physical lessons, contact +263 771 777 876. I hope you are well. I hope you are okay. Be blessed and stay blessed. This is Chico Squared, the maths and science guru. Chakwe ndachibaba.